This is going to be a pretty short keynote, probably like 5 or 10 minutes, mostly just because I got to pee and like I need some more coffee. So I've got stuff I got to do. Sorry, it won't be that interesting. Actually, like I'm hoping to get across some points that I think are really important about embedded security in general, but especially IoT. And one of the ways that I'm going to do that is by showing a lot of weird pictures. So I'm kind of thinking about this from the perspective of more of an artistic keynote, right? Like I've got a lot of buddies that do really great keynotes. I'm not the best keynote speaker. Alex Stamos, as you probably just saw, just gave an excellent one at Black Hat. I worked with him for many years, and he is definitely one of my heroes when it comes to speaking. His style and our other friends' styles are a little bit more traditional. I'm not a traditional person. I'm kind of a nutbag, so you're going to see a nutbag keynote. But I am pretty serious about the trigger warning. If anybody is, uncomfortable around dead things or insects or cutting, like, you should probably not be here. So what I'm interested in kind of thinking about is the relationship that we have in Internet of Things to the relationship that information security industry has as a whole, right? That's pretty much been the focus of my career. I got started in information security back in 1999. And to me, I always thought my perception of what information security was supposed to be was this mechanism for reducing risk for consumers, right? I wasn't really hip to the whole government thing yet. I didn't get ensnared in that until only a couple of years later. But my vision of what information security meant was this giant sinkhole where you would throw pretty much all of your junk, all of your bullshit, all of the unnecessary crap that goes along with designing systems, and it would just end up funneling into essentially like this, singularity black hole and kind of disappear into the ether, right? So I had this really bizarre, misconceived idea of what it is we do at information security. And my perceptions were so off base that I think that what we've done over the past few years is result in essentially what these young ladies are trying to depict in this, what I think is a really beautiful picture that's a metaphor for life, really, in information security. All we do is talk. And talk and talk and talk and talk and talk about bugs. But we actually blind each other from seeing what they mean and where they come from and what they're composed of and what they actually have to do with our world, I think this is the biggest and most disappointing thing about my experience in information security. We don't communicate, period. So when we see new technology coming out, the usual punditry wheel starts spinning, and we hear a lot of nonsense. There's a cool new camera, or there's a cool new watch, or there's a cool new whatever. And we ignore what's going on with the technology, where it's coming from, where it's evolving, how it's growing, what it's selling like, what's the price point, what's the manufacturing look like. And we start talking about how much bullshit there probably is in the technology, and completely ignoring the engineers that likely put a lot of work into ensuring that technology works correctly. Great example recently, Face ID. How many people raise your hand if you thought Face ID was going to be a complete joke hackable by a picture that you can hold in front of a camera? Anybody? Feel free to raise your hand because we all had that thought when it first occurred, right? I had that thought too, but then I remember, oh wait, we know some really smart people at Apple, like Snare, and a bunch of other people that probably are smart enough to think that same thing and then maybe test it, right? So if we consider that for a few seconds after our first initial thought, you can kind of think about this as a process of engineering, right? You're no longer thinking about it as like, this must be a complete failure. This must be a complete nightmare for its users. No, well, how about the engineering process that actually reduces those risks, classifies them, and ensures that we can do something appropriate, right? Like that to me is the really cool thing. People get really, really excited about vulnerabilities, and they get excited about the next new hack instead of actually discussing the underlying risk. Another problem that we have is fetishizing. So bug fetishizing is a big, huge problem in our community, right? What's the latest bug that everybody's gotten super excited about? Throw some names out there. Anybody? There you go. So the latest Bluetooth vulnerability, which I can't remember the name. Yeah, I don't know. Blue something, it's got a website and a cool logo like every other freaking thing, right? But point being is this is actually a pretty important vulnerability. The Bluetooth vulnerabilities are massive, right? So they've been around for a long time, and they affect 1 billion devices or something like that. That's fine, but it's actually super easy to remediate that, right? Turn off Bluetooth. For those that can't turn off Bluetooth in embedded systems, that's a much more challenging issue. But instead of talking about how we can actually remediate that as a potential threat, really what a lot of people have been doing is using it to raise money, right? So we see that in our community all the time. We use it to raise money, not only as startups, but internally. So people want to increase budgets for whatever they're doing, whether it's project management, they want to create a new tool, they want to create more access for the researchers to go to conferences, whatever. This is fine, but we're actually creating an environment where people are more interested in how cool a new vulnerability is because they can use it to their advantage, rather than actually taking that vulnerability and minimizing the risk to consumers, industry, government, et cetera, right? So I get a little bit tired of hearing these issues over and over and over because really there's nothing new about this new bucket or batch of Bluetooth vulnerabilities. It's just a new set of stuff that's been found in the same old crap, right? Like there were vulnerabilities in remote Bluetooth a couple of years back where you could get root on Android devices. Well, now people did some excellent research where they were fuzzing and they got Apple, Android, Macs, Linux RCE. Great stuff, excellent work, but this isn't new, right? In fact, I'm kind of privy to this particular research. I actually knew about it 6 months before Black Hat. And it was proposed to me the idea that should this be a talk at Black Hat? And my opinion was, I think that it's a great talk from the perspective that people will want to know the technical details. I certainly would want to know how to hack 1 billion devices, right? But is it new? Is it something that Black Hat is going to give a shit about? My conjecture was no, right? Because it's not actually new tech. It's same old rolled up vulnerabilities packaged into a new exploit layer and a new exploit tool with a cool new name and a cool new website, and check us the fuck out. But it's not anything new. It's not usable. It's not anything that's pushing the industry forward. So did you see that talk at Black Hat? No. Right? Of course you didn't. The other big problem for me is the romantic nature, if you will, of bugs and how they develop, right? Because this is really all about the sexual nature of vulnerabilities. And what I mean by that is reproduction, right? When we see vulnerabilities in the wild, what we're actually seeing is something that's been reproduced 1 million fucking times. XSS, RCE, whatever it is, we've done it to death. But we're not actually reducing those vulnerabilities in any significant way. We've got ASLR, that's supposed to help with RCE, right? No, not really. What was that, Halvar's team, Thomas? His team had, do you remember who actually did that work, guys? The ASLR work? I can't remember. I can't remember anybody. Somebody on Project Zero just did a great piece of research on ASLR and how you can actually determine kernel addresses, kernel ASLR affected addresses by abusing false positives or false negatives in the cache on your local processor. So you can actually identify whether a page exists in kernel memory just by using the cache correctly. which allows you to know which pages in memory exist and which ones don't. So if you're attacking a kernel and you need to know which of those pages are ASLR, where they exist in memory, you can use this attack to basically create a fingerprint of what the kernel looks like in space without actually having to worry about ASLR. So if you have a vulnerability that allows you to elevate the kernel, but the only restriction, the only constraint is ASLR, and that one hump or that one jump is the only thing holding you back from being able to compromise that system, well, you're pretty much good to go, right? Because according to this research, the way that we thought protection mechanisms worked in CPUs completely fails. 100%, because CPUs were never designed with the intent of ASLR as a security mechanism, right? ASLR is an add-on that we've used as a construct in operating system theory to ensure that these regions of memory are somewhere arbitrary, because our concern as engineers in operating system design, application design, is that somebody's going to abuse this vector of memory. CPU designers don't give a shit about any of that. And why would they, right? Because that's absurd. So when you're building a cache, you're not building a cache for a CPU that actually takes into account, address space layout randomization. Nobody wants to build silicon that actually is going to do anything relevant with that or protect against those kinds of cache vulnerabilities. So of course it's going to work, which was exactly the kind of logic that led this researchers to think like, hey, maybe I should check this out, right? But this is one of those security guarantees that our entire industry depends on. And yet, when we're implementing technology, we don't take the time to actually identify whether these guarantees are enforced by the underlying technology. And this is what I mean about the sexuality of information security. Because when you create architectures and environments that incite these types of behaviors, you're perpetuating the behavior to occur over and over and over. It is literally like a virus. You're reproducing the behavior, sexually or asexually, depending on the type of vulnerability. But it's occurring, right? This is the nature of vulnerabilities. Another problem that I see all the time is that we are so willing to make the giant, scary, what should be terrifying vulnerabilities into pets. And how many times do we see that, right? We just talked about the Bluetooth vulnerabilities. It's the exact same thing with this vulnerability. The recent Wi-Fi vulnerabilities in embedded systems found again at Google Project Zero. These are great examples of vulnerabilities that can be remediated very, very easily. But those are the ones that got the giant press because these are the vulnerabilities that are extremely difficult to exploit, extremely difficult to find, extremely difficult to reproduce, right? So we get excited and we think, oh my God, this is the coolest thing ever. Let's focus on these absurdly difficult, intricate vulnerabilities rather than on the mitigations that will defend against them. A really cool thing that I like to think about when it comes to the Google Project Zero Wi-Fi vulnerability, and I talked about this with an IoT client of mine recently. They were concerned, are our modules going to be affected by this Wi-Fi vulnerability? Should we worry about this technology? And I said, well, okay, what does your architecture look like? And they said, well, we have an application processor and we have the Wi-Fi module. And the Wi-Fi module is potentially running the same code that Google Project Zero exploited, but our application lives on the application processor where it's supposed to. So I said, okay, are these systems using shared memory of any kind? No. What kind of resources are they sharing? Just a bus, serial bus, standard SDIO, send message back and forth and which packets can get sent, which packets are being received. Okay, so is all the critical data that's actually traversing over Wi-Fi encrypted? Yes. Is it encrypted using keys that are on the Wi-Fi module or the application processor? The application processor. Well, there you go. Not a single thing of importance is actually executing on the Wi-Fi module. No data that's relevant to your application is in clear text on your Wi-Fi module. The Wi-Fi module has absolutely no peripheral access to anything that could tamper with your application environment. So why do you care, right? That kind of logic is more important than thinking, oh crap, there's a new Wi-Fi vulnerability that's absurdly difficult that everybody's going to start owning the shit out of everything with. That's not realistic, right? We're fetishizing and creating pets out of vulnerabilities that are beautiful and giant and complex and interesting. And yes, they're dangerous, but they're dangerous more so if we obsess about them instead of thinking, how can we remediate them, right? Another fascinating thing about our industry is taking extremely small issues and blowing them up, right? Almost making them seem elegant. Like, I love this tiny little lotus mantis. It's a beautiful, beautiful bug. It's one of the smallest bugs in the world. And it reminds me of a lot of vulnerabilities that I see when I'm doing consulting work, because people want to talk about, especially in IoT, oh, well, passwords are a critical thing, or this or that is a critical thing. How are we going to remediate, admin across 1 million boxes? Like, well, you probably should have thought of that in the design of the actual device instead of waiting until it was deployed before, you worried about this entirely simple thing to remediate. So when we take too much time to think about these issues, if admin is our biggest issue when it comes to rolling out a new IoT technology, we've failed as engineers, right? Because that should never be a question. Nobody should ever have to think, is a password going to compromise a massive scale deployment of devices? Ever. In 2017. God forbid that ever has to cross our minds. I just find this absolutely absurd that anybody would consider it, right? But it does. And think about the amount of engineering time that it takes, okay? The amount of engineering time that it takes to actually swap out a password interface with an SSH interface that has public keys encrypted that are locked into some kind of secure element, that's actually a small amount of time. When you juxtapose it alongside of the time that it takes to deploy a password-based systems for admins to log in with, and then you have to remediate it later when there's a massive botnet issue related to your password mechanisms, right? You're talking about millions of dollars in potential fallout later instead of maybe a couple $100,000 at most at the beginning stages of your product. And that, I think, is something that we're really missing as an industry. We're not selling what the best decision is. We're selling what's the easiest to deploy today, getting our little check marks in there, and then signing off on the product to launch. These are mistakes that we're making that are causing failures to cascade, not only in our own industry, but across multiple tiers of verticals, right? I mean, we're talking about automotive systems, wearable systems, industrial systems, government systems. Pretty much everything in IoT is affected by this logic. And yet, we make the same mistakes over and over and over, which is why we just saw the Dyn botnet occur, why we've seen multiple botnets that are now starting to actually harvest Bitcoin, all based on the most simplistic things that we could possibly do, right? And that's very frustrating, because I think we can really do better. And I think, for me, the biggest issue, and I kind of just touched on that, is cost, right? And so when you think about a bee entering your body, right? Is this something that has a tangible cost or a threat? Sure. We swallow our own bullshit all the time in information security, and we usually get stung because of it. Because that bee that's dead on your tongue, it's still got a stinger. And that stuff usually affects us negatively over and over and over and over. And the cost of swallowing that little pill is exceptionally large, especially when we think about cost from the perspective of IoT, okay? When we think about cost, it's really related to deployment. So just out of curiosity, how many people have deployed an IoT device here? Have been involved in production, manufacturing, building, securing, whatever? Anybody? A Couple of hands, awesome. That's great. One of my biggest concerns with cost is that as an industry, we're not pushing for a decrease in cost. So that when we're swallowing our own bullshit, it's not actually biting us from the inside out. And what I mean by that is let's look at here's a really simple example model, right? Most of the technology in IoT today uses what kind of CPU? Anybody? ARM. How much does it cost to build an ARM processor? Anybody know? A shitload of money. I swear I heard somebody say shitload. You're accurate if you did. So pay to play model in ARM. It's like $1 million up front, right? It takes an average after that of 2 to 4 years to be able to actually design your own silicon, get the IP license, get everything rolled out, balled up, and ready to go. Once that occurs, you've probably spent another $500,000, a couple $1 million in IP licensing and all that other stuff thing. Once you're actually deploying your proof of concepts, you go to TSMC or some other fab, maybe you go with a shared wafer model. I don't know what you're going to do. Depends on your organization. But you're likely to spend another couple $1 million in proof of concept chips. So you've got a handful of proof of concept chips. Okay, good for you. Now you spend a couple million more. Now you're ready for an actual rollout once you do all of your finite testing, silicon review, blah, 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 blah. And then you go with your deployment and you've got a couple million more dollars spent actually doing the manufacturing of the real roll, right? So now, just to get out the door, you're probably around $5 to $8 million, right? And that's just for a bare bones ARM CPU. I'm not even talking about a Cortex-A. That's basically like Cortex-M, like maybe a M4F, right? Which is absurd when you think about how much they cost in the market. I can buy a Cortex M4F raw with TQFP packaging for 99 cents off Mouser. So if I'm spending multi-millions of dollars up front to get a 99-cent chip that has absolutely no security technology in it whatsoever, except maybe hardware AES, like whoop-de-doo. What does that actually mean for the application that I'm building? Because I just spent tons and tons of money building something that really doesn't have any value. And I'll talk about why it doesn't have any value shortly. Because if you don't have security technology built into the hardware in IoT, your product will fail. Period. That is the only thing that can occur if you have a poorly designed architecture model in IoT. So from a cost perspective, we're spending all this money as organizations building technology that's doomed to fail. And yet we don't change this model, even though we're in the face of all this evidence that tells us this is ridiculous and awful and we're actually hurting our world. Right? Let's look at a different model. RISC-V, excellent processor design, very elegant ISA. I'm actually, full disclosure, I'm a part of the RISC-V consortium. So I'm on the debugging team, security team, and ISA team. Point being, there's a reason why I'm there. And it's not to pitch RISC-V to you. Make your own decisions. But I will tell you the cost model. It costs about $250,000, so $250K up front as a participation model. And then once you pay that, everything is open. It's 100% open source. There's no licensing fee. With ARM, you have to pay a percentage every single time that you sell a chip. And you negotiate that with ARM based on your volume, right? So you're selling, every CPU that you sell, you pay an extra 2% kickback to ARM. With RISC-V, there's none of that. And that's why I'm so interested in the RISC-V model, because for the first time ever in CPU design, we have an opportunity to put in the technology that's required to build secure IoT systems from the ground up for a superficial cost. In ARM, to incorporate a secure element, the additional silicon for that, it's a ridiculous amount of money and time. And negotiations, licensing fees, whatever you're going to do. With the RISC-V, it's a drop-in. You're literally just dragging and dropping stuff in a UI that says, hey, add this silicon over here to create a secure element. That is fucking cool. And it's important for our ecosystem because now we have an actual option that lets us build that same 99-cent processor but a 99-cent processor that has capability that's usable by the people that need it, not just for consumers, but for government and industry and whatever else. That's really exciting. So now that we've kind of talked about the bullshit in IoT security, or I guess our information security industry as a whole, we're going to talk a little bit more about the gift of information security and threat modeling, which to me, I think, finding bugs that are useful and beautiful is a great thing, but actually doing something with them is more important, right? So the next part of this talk is really about what are the real models in information security in IoT that we can resolve, because there are entirely new classes of security flaws in IoT that can't be resolved without the technology that I just talked about, the cost-effective technology that I just talked about. In fact, if you are a giant company, you can literally just get held in stasis by one person that wants to completely dominate your organization. In an IoT model, if you build your architecture incorrectly, somebody can bankrupt you in an hour. Anybody have any idea how? You can throw it, just shout things out if you want. Reputation. Absolutely. Anything else? Bug bounty. I love that somebody mentioned bug bounty. Thank you for doing that. Anyone else? Come on, one more. Fines. Thank you. Beautiful. Fines. Let's talk about fines. So to me, one of the interesting things about fines is they always start out small. And I guess I don't necessarily mean fines from the perspective of, somebody, the FCC is going to fine you for doing something incorrect. What I really mean is, the cost of doing business, right? So whether you're being fined by the FTC, FCC, you're being sued, you've got insurance problems or whatever, there's a growing cost over time. And this isn't just true of when you're failing, it's also true when you're just doing business every day, right? So a lot of API models that are out there with IoT, you have to pay every single time that somebody sends a message to it, right? So what's really fascinating about this, if you have a poorly designed security model, or just an IoT architecture in general, you're deploying a massive amount of devices that all have to talk to your API. That API charges you a cost every single time that you have an endpoint sending a message to a backend system. So if anybody can arbitrarily send messages to the system, and the system costs money, then somebody can figure out a way to actually upcharge the system to a massive degree that will cost you hundreds of thousands of dollars in a small period of time. In fact, in my consulting practice at Loudmouth Security, we regularly consult with information security organizations, but also primarily with IoT organizations. IoT companies that are developing new technologies, startups, and existing embedded systems companies that are building new technology. What's really fascinating is that over the past couple of years, I've found that the design of APIs in IoT and the cost of doing business is such that you can actually exercise an API to the point where you can massively upcharge an organization over the period of several hours. And if that company is a startup, you can actually bankrupt them. And this is really a fascinating finding because we're kind of flipping the model of IoT security from what it used to be considered, which was like, oh, this is all about passwords and people's homes getting broken into through their toaster and shit like that. Like, yes, some of those things are important, but again, as I discussed earlier, those are actually quite easy to remediate, right? What's not easy to remediate is when you've deployed an incorrect architecture that allows anybody worldwide to start pinging your API infrastructure, upcharging your model, and you can't do a single thing about it. There's absolutely nothing you can do. There's no way to remediate it. There's no way to shut off those endpoints. There's no way to differentiate between an endpoint that's valid and an actual abusive, malicious individual. Or maybe just a hobbyist who had a script that they didn't even realize was, in a while loop sending data to your API. I always bring up this example because I just find it absolutely fascinating. But, we're what was it, 7 years ago now, there was a young lady that lives in New Zealand. This is my favorite IoT story to tell, because I literally tell it all the time. But she had very little money, lived in the middle of nowhere in New Zealand, and really wanted to access videos. She didn't have enough money to pay for television, so she thought what she would do is crack open one of those gas meters or power meters in her home that happened to have a cellular unit and was uploading metrics over the air to the energy company. Had a SIM card. She popped the SIM card in her laptop and started watching videos, right? So she's literally watching TV through this service, and nobody figured out for several months. She actually racked up about $250,000 in charges from the wireless organization that just didn't realize what was going on. And when the energy company got the bill, they were like, oh shit, what exactly happened here? So they tracked down the ID of the SIM card to the actual radio that she cracked open, figured out who it was, and had her arrested. Now you think about this, a young lady in the middle of nowhere in New Zealand that actually has to steal from her energy company to watch television. Is she ever going to be able to pay back $250,000 in fees? Clearly not, right? And this is what I'm talking about with IoT models today. Who ends up paying for that? Is it the company that actually deployed the radio? Is it the company that put together the APN for the wireless network? Is it the carrier? Who actually eats the cost? Insurance? Who knows? Because we're talking about conglomerates in this particular scenario, I'm guessing somebody just wrote it off at some point, or a couple of people did. But if you're a startup and you get that bill, especially if you're a nobody startup that nobody has a clue who you are, somebody's going to pretty much say like, yeah, you're paying for that, right? Because you have no, somebody mentioned the word reputation earlier, you have no reputation to save you. If you're a large conglomerate that does business like this all the time, yeah, you're going to be able to get away with this kind of stuff because people know who you are, they know you make money, they understand the revenue stream, and they're going to let you get away with it. If you're a new startup, you're going to be paying for that fine, and your company is going to be really, really hurt. And what's going to happen when you suddenly have $1 million or so in fines like this, and your venture capitalists are coming to you saying, where the fuck is our money? $1 million just disappeared because your engineers don't know what they're doing. This is ridiculous, and we're going to liquidate everything you have. That's the reality that we're in today. And wearable technology is fascinating too with this perspective, right? Because wearable technology doesn't actually connect anything, it just connects through stuff. So what's really fascinating about this to me is that most wearable technology, except for the new Apple cellular-enabled watch, basically has to route through something else. So the trust model is really fascinating. You're actually creating a proxy of trust, right? And we live in this new sensor network, extended world of fog computing where the edges are completely blended. And without the right architectural model, we can't actually tell what anything is, where it's coming from, or whether we actually have valid data. Like, there's no way to know what the origin of information is, right? So whether it's a watch or a sensor coming off a wall or God knows what, I can't make any guarantees about where that data is coming from. Now, if I'm in a startup, what do you think somebody's going to say when I'm going to go to my potential clients, my customers, my partners, and say, I'm going to give you this really awesome suite of metrics, right? All this information is going to be valid for you. You're going to be able to use it to, build information about where people are driving or what kind of food they like, where they're standing in a grocery store, all this great stuff. And somebody says like, well, yeah, I mean, that's cool. It sounds great. But how easily can somebody game that system? Like, I'm going to put my trust in using this information to create metrics that are going to allow me to spend millions of dollars in marketing, but based on information that can be completely gamed by my competitors? Why would I do that? Why would I ever invest in that? So to me, this is very suicidal, right? You're talking about building an architectural model that results in bugs that can completely cripple your business because there's zero trust. And I've seen that multiple times now over the years. A startup forms, they basically say, hey, we're going to do this really awesome stuff, but we can't actually validate or create attestation on where the information is coming from or whether or not it's validatable. and then potential partners walk away from multi-million-dollar deals because it's just no longer worth it. They can't trust the information. So this idea of attestation really falls back to the idea that we talked about a few minutes ago, which is cost. If we can't create cost-effective architectures that allow us to build secure systems that we can have attestation on, that we can have point of origin on, that we can have some semblance of trust. If we don't have that as a component in the architecture of IoT systems, then those systems and the businesses that they're built on will fail. Another major problem is understanding where the vulnerability actually lies. Because things are deceiving, right? You really never know what's actually attacking you if you can't tell what a device is. I can look at two separate insects, but how do I know which one's actually more poisonous? Is it the mantis or is it the scorpion? Obviously, I would go with the scorpion, right? But it turns out that the mantis is actually way more aggressive. Scorpions just kind of stand there and don't really know what to do, right? But a mantis just wants to chop your head off. And in the real world, when we're looking at IoT systems, it's the same problem. If you don't have authentication and you don't have the ability to do attestation on a system in a secure way, you cannot differentiate from one system to another. You cannot be able to define whether a system is maliciously owned or whether it's just a device that's acting incorrectly, anomalously. Behavior anomalies in IoT is critical toward understanding whether or not that system has any sort of abusable flaw or has been abused by an adversary. Without those metrics, there's absolutely nothing we can do to identify whether or not two systems have failed in different ways, malicious ways or just due to hardware failure, faults, whatever. So again, this all goes back to that security layer that we don't have because of costs, a cost problem that's not been resolved by information security because we're too busy worried about way different stuff. We're worried about bug bounties, and we're worried about creating nonsensical, security barriers around who knows what, right? We're actually protecting the wrong things. We create boundaries that are based on our fears instead of what's based on tangible information. And that, to me, is the most critical part of information security, or critical failure, to me, in information security, is the redirection of what we should be focused on based on how people can actually make money. And somebody brought bug bounties up a minute ago. I would really like to focus on that for a second. I'm a big fan of bug bounties. But let's look at bug bounties realistically. What do? Do they reduce bugs? Or do they provide the perception that they reduce bugs? I would presume the latter, because the evidence shows that it is the latter, right? Because what's not actually occurring is we don't have bug bounties that say, how do we eradicate this class of vulnerability? No, we're just going to pay out $1,000 for every XSS, another $1,000 for every blah, 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 right? That's the number that keeps increasing on the tallies on bug bounty websites. Nobody's actually creating a bug bounty that says, let's eradicate XSS as a whole. Let's eradicate RCE. Let's eradicate this, that, blah, blah, blah. Nobody's doing that. Why don't we have those bug bounties? Is it because the bug bounty companies would be out of business if that actually existed? Probably, right? So when you think about it, a lot of what we do in our organization, our industry, is focused on the perpetuation of our industry. It's not actually focused on the reduction of these issues. And what's fascinating is over time, we're actually seeing our industry fail in a way where we're being consumed. Has anybody noticed this? There are fewer information security consultancies worth a damn today than there were 10 years ago. And 10 years ago, they were probably 10. This is a very telling statistic, especially when you relate it to the size of our industry, okay? Most organizations are not doing groundbreaking research. There's a handful of organizations that are doing groundbreaking research. And I can name them all on one hand. I'm not going to, but I can. Point being, relative to the size of the industry, we're worse off today than we were 10 years ago. Again, because companies are starting to understand the cost model of IoT security or security practices in general, where they're saying, hey, wait a second, these guys that specialize in information security are really good at what they do, but it costs an enormous amount of money to be able to outsource to them for their skills. I don't really feel like paying somebody $750 to $1,000 an hour for security expertise when I could hire somebody full-time for $120K. Especially now that we have, universities that are pumping out degrees in information security, reputable universities as well, and other organizations that are willing to provide services to create that kind of educational gap or close that educational gap that we've had for years. So yes, it's true that we have an information security industry that needs more and more and more and more people. Yeah, I dig that, that's fine. It's true, but who needs those people? Consultancies that are breaking ground, or companies that are just like, oh yeah, we need some information security guys, that's important. We've learned that's important, we know that's cost effective, we're gonna take them on. The latter is true, which also tells you how much groundbreaking research is being done in our field. 0%. When you look at the enormous size of our industry today and the number of people that are doing groundbreaking research, it's literally 0%. A fraction of a percent is how much research is being done today. That is an indication that information security is dying and that we are being consumed by engineering as a whole. Now, you might think that's a bad thing, but it's actually good. The reason why it's good is because we're evolving the engineering industry around us, or the engineering complex, right? They're actually starting to listen to the things that we've been saying for 20 years. And as a result, they're actually taking that on, which is a really beautiful thing. And the end result is that we no longer have to have nuclear weapons to fight these tiny little bugs. We don't need to use missiles and point them at some kind of, God knows what XSS vulnerability just to kill it off. We don't need government-sized security in order to succeed. All we need is a little bit of a push, and we can knock anybody off if we want to. We're actually getting really good at reducing problems. We're getting really good at integrating ourselves in with other organizations and other industries. These are positive things. So even though I'm saying the information security industry is dying, and it is, it's actually a death that I'm quite happy about, because it's a death that we've earned. So I'm not just actually talking about these issues, right? I'm also putting them in practice. So I recently disclosed a vulnerability to Apple, a very widespread vulnerability. I can't talk about it, unfortunately, today in detail. I'm hoping to talk about it, or I intend to talk about it at Hack in the Box 2018 in Amsterdam. So hopefully all the details will be out by then. But the issues that I've been talking about today, the models where we're suddenly flipping everything on its head, they're real, they're tangible, and they're much, much more difficult to resolve than all of the piddly bullshit that we've been talking about for 10 years. That's where people need to be focusing on research. And if you're interested in IoT security, I would really implore you to talk to me a little bit more about what these concerns are. But there are vulnerabilities out there that basically allow you to manipulate pretty much any endpoint you want, which to me is really fascinating stuff. So before we go, there's actually one more thing I'd like to do, because I'm hoping, and this is part of the little I'm a little bit nutty thing, but there's a really amazing poem by Charles Bukowski. Anybody familiar with Bukowski? Raise your hand if you are. Really? One person? maybe 2. All right, well, he's my favorite author, right? And what's really fascinating about Bukowski is he wrote extensively about the faults of human beings, right? He was always down in the trenches, the dirtiest bars, dealing with the dirtiest people, drinking with the dirtiest gin. He didn't really care, what he was doing as long as he was doing something passionate. And that reminds me of the security industry. So I'd actually like to read this poem. Which starts with, if you're going to try, go all the way. Otherwise, don't even start. If you're going to try, go all the way. This could mean losing girlfriends, wives, relatives, jobs, and maybe even your mind. Go all the way. It could mean not eating for 3 or 4 days. It could mean freezing on a park bench. It could mean jail. It could mean derision, mockery. It could mean isolation. Isolation is a gift. All the others are a test of your endurance, of how much you really want to do it. And you'll do it, despite rejection and the worst odds, and it will be better than anything else you can ever imagine. If you're going to try, go all the way. There is no other feeling like that. You will be alone with the gods, and the nights will flame with fire. Do it. Do it. Go all the way. You will ride life to perfect laughter. It's the only good fight there is. Thank you for your time.